So my name is Lauren Rose and I'm a math professor here. So I'll put my name, Lauren Rose. I live in Red Hook, New York. And I like math. And oh, tell me your favorite puzzle or game. Okay, I'm gonna put Scrabble, although I'm not sure it is anymore. Okay, so if you can hear me and you would be willing to put that information in the chat, that would be great. You can also unmute and talk to us as well. Okay, Sophia is from Ukraine, math and physics. My favorite game is Mafia. Okay, sure. I'm Leah, I'm from California and I like Sudoku. Now Ukraine, what time is it in the Ukraine now? Is it? Okay, Xander, okay, is from Traverse City, likes math, science, music. Okay. I'm from Pakistan. I'm interested in studying math and or physics. My favorite game is Scrabble or chess. Oh, it's in the middle of the night. Okay. So if you guys, if you're okay sharing your screen, it would be great to see you. If not, if your bandwidth doesn't permit it, it's fine. Also feel free to unmute if you like. Okay, math or physics. Okay, so we have, my camera is broken. Okay, that's all right. So well, let me just see. So we have Leah, Sophia, Xander, and let me just get a sense. So Leah's from California, likes Sudoku. Great. Xander is from Traverse City. By the way, Xander, I'm from Michigan also. I'm from the Detroit area. Math, science, music, and labyrinth. Sophia's from the Ukraine, math and physics. And Robbie is from Pakistan, interested in studying math and physics. My favorite game is Scrabble or chess. So, you know, it's interesting. So, so how many of you also, maybe you can like raise your hand or put something in chat. How many of you saw the video of this class before coming? Do you know how to do a reaction? So you can like do a thumbs up if you saw it. You can also do the reaction. I think the reactions you can even say yes or no. Maybe, not sure. So we don't have, let's see. So I'm not hearing anything from them. Can you put in the chat yes, if you, yes or no, whether you saw the video, the 12-minute video that was a prep for the class? Hello? I did not. Okay. Started to, but didn't finish. No, I did. Okay, great. Yeah, as I said, feel free to talk. So I'm, if your interest is in BARD, then I have to tell you, you cannot hide in a classroom. Our classes are small and there's a lot of interaction. So if you came hoping to have a lecture, this maybe is the wrong class. So I hope you don't mind. If you really don't want to participate, it's okay, but I will invite you to. And I will also invite you to use your, you can keep using the chat, but you can also use your, just unmute and just talk if you'd like. So, okay. So now the video that some of you saw was about this course called The Mathematics of Puzzles and Games. And it's actually a course for non-majors to get them kind of excited about math. Since most of you are interested in being science majors or math, I'm going to actually do this differently from the way that I thought. So, so I just want to tell you, so in this class, we do the Rubik's Cube, we do the game of set, we do Sudoku, and we do something called NIM. And what we do is we learn to play the games, but then we analyze them mathematically. Now, the only thing is if you are interested in math or science, you probably wouldn't take this class. However, one of my fields of interest is called, put in the chat, is called recreational math, where I study objects like games mathematically. So let's see. Oh, what are the favorite games? Scrabble, chess, Labyrinth, Sudoku, and Mafia. Okay. So I want you to put in the chat whether you know how to play the game Set. Has anyone ever played the game Set? Just say yes or no. If you're not sure what Set looks like, it looks like this. No. Wow. 3 no's. Okay. So I'm going to teach you this game. That's fine. I'm going to teach you this game and we're going to, I'll change these are, well, this is sort of Set. I better go back to the real Set. Okay. All right. So this is a very popular game. It's a pattern recognition game that you can teach it. You don't even have to know how to read. But I'm going to tell you, I'm actually going to be, I guess I'm going to be a little lectury for a moment. So, so let me start here. Okay. So I'm going to use something called a Jamboard. And I'm going to share my screen. Okay, so this is called a Jamboard. And this is how I do a lot of online presentations now. So that's my name and that's my email if you have any questions. Mathematics of Puzzles and Games, as I said, it's a course for non-majors, although I often have math majors as course assistants. But I also incorporate puzzles and games in my upper level math classes and in my senior projects. So I'll tell you a little bit more about that soon. So I want to tell you a little bit about the card game Set. So this game was invented by someone named Marcia Falco. She's a geneticist in 1974. She was trying to understand whether epilepsy in German Shepherds was inherited. To track the individual traits of the dog, she created cards with blocks of information for each dog. Now, the last time I gave this as a talk, people were like, what, how did she do that? And I realized I don't know exactly what these are supposed to mean. They may mean something about different DNA sequences. However, what she didn't realize is that this game has so many mathematical properties connected to geometry, probability, linear algebra, combinatorics, and way more. And so that's why I end up using it in my classes. And there's also some really interesting research problems. So if you're considering BARD, you might be aware that we have a senior thesis, a senior project that every student has to do. And if you choose math or science, you will actually be doing independent research in that area with the guidance of a faculty member. So I have actually supervised several senior projects on this game and several summers of summer research. We also have a BARD Summer Research Institute where students get paid to work with faculty members in the sciences and social sciences. So anyway, so let me just go on. Let's look at the game. Okay, now first of all, I used this Jamboard before, so everything is a little messed up. Okay, so here we go. Now I would like a little interaction. If you're willing to yell things out, that would be fine. So since I think no one here has played Set before, let me just look back at the chat. I do recognize the cover. Okay, great. So so this game came, so now, by the way, this game usually has 81 cards, but I find to teach it that I like to start way smaller. So basically, if I take these 2 cards, so someone put in the chat or just yell out, what do you think the third card is? Just what makes sense?
The single diamond.
That's correct. Okay, so that's okay. So now, what if I put the 3 of diamonds and the 2 of ovals? What do you think goes there?
The single squiggle.
Single squiggle, that's correct. Okay, so So it doesn't seem like it should be too hard to find a set. So what I'm going to do now is I'm just going to put these, I'm going to put these randomly. I can actually just move these around. So I'm just going to sort of go randomly. And so the way the game is played is you'd put out a random selection of cards. And then I would ask, is there a set here? I'm thinking of these 5 over here on the right. So ignore these. So does anyone see a set? What you think would be a set? So it's one thing to actually figure out one. If I give you 2, it's another thing to figure out if there is a set here. Does anyone see something that they think is a set?
Yeah, well, 1 diamond, 2 squiggles, and 3 ovals.
Right. Okay, so this 9 cards is super basic, but I like to teach things from the ground up. It's a great way if you're or want to study math or science. Okay, so now we're moving up. So this is set 27, and now we have, instead of those 9 cards, we have 3 different shadings. Okay, so we're gonna, this is kind of a fun little board here. So we're gonna look down where it says number 1, complete the sets. So can anyone call out what you think the third one is for this one right here? This question mark.
3 open ovals.
3 open ovals, and you got it. Congratulations. How about this one? And I don't know who's talking. Are there different people talking, by the way? It's not always the same person, is it?
No, it's not.
Oh, great. Okay. So let's try this. And by the way, you're allowed to be wrong. If you are not wrong ever in a math class, you're in the wrong class. Okay, so now what happens? What does someone think? Xander, you want to tell us?
Would it be 3 sort of half open diamonds?
I think you're right. Excellent. Okay, now this is harder. Can you find these sets? Now I numbered them. So do you guys know how to annotate, by the way? Do people here know how to annotate? If anyone's on a Chromebook, it might not work. But so let me just tell you how you do that. So if you look at the top, it says someone's screen sharing, probably Savannah. And then it should say, oh wait, I'm sharing, sorry. It says probably Lauren Rose's screen sharing or something. And then it says view options. If you click on view options, you can click on annotate and you'll get an annotation palette. And then you'll be able to, in your palette, you'll be able to like draw. And you can do other stuff too. You can do stamps. So, and you can do it way over here if you want. So why doesn't everyone see if you can annotate something? Sophia's able to annotate something, and you can, if you want to do it on the white part, you can. Anyone else able to? If you can't, it's okay. Or if you have a question, let me know. Now, by the way, oh, good, Robbie, you got it. Leah, okay. And, okay. So now, fortunately, I mean, I taught remote all last year, so I had to do stuff like this. Fortunately, we're actually in person. If we're in person, I would actually just have a deck of cards on each table and we would just play with them. But I'm trying to give you a little sense of what we do virtually. So now my question is, and I'm going to clear everything. And over here on the side, I'll put some hearts here. And you can also put them in the chat, although Savannah, if you can tell me if there's, I can't always see the chat from the way I'm now. So what I want you to do is tell me if you find any sets. And so we have 1, 2, 3, 4, 5, 6, 7, 8, and just list the numbers if you notice any. And you can just put them here. If you want, yeah, you can draw them or you can use the text tool. So I could write like, so I'll give you the, like I could write like 1, 2, 3. The only problem is 1, 2, 3 is actually not a set. So you could write something, you can type or draw over there, or you can yell it out, or I'll try to find the chat. And so I want you just like take a minute and, you know, I hope you realize that you're actually taking a class here. I don't know if you thought you'd have to think here, but BART is a place to think actually. Okay, so 156. Let's see, 156, yeah. You have all threes, okay. And are there any others? 4, 8, 5. Okay, they're all open. 1, 2, 3. Oh, so Xander said 2, 5, 7. Can someone do write 2, 5, 7? Let's see if it works. 2, 5, 7. That's good.
Does the order of the cards matter at all?
No, that's a very good question, but no. Two, 5, 7. That looks good. 4, 8, 5. No, that's great, although that's a duplicate, so but that's okay. 7, 8, 6. Now, I can't, you know, I haven't done this draw. I can't remember whether there are 4 and 5. I know there's at least 4. I don't know if there's a 5th one or not. So let me just see. Oh, yes, there are 5. Thank you. 1, 2, 4. Yeah, I think you found them all. There's just 5. Okay. Good job, everyone. Yeah, this is a super fun game. I mean, you can, you know, you can buy it, or you can like even in my puzzles and games class, I have the students make their own cards and they can make their own designs and stuff, and that's kind of fun. Okay, so we found the sets. Now this, we're not going to play on this app. That's kind of an old sort of app. So so we're going to move on. So hold on a second. Uh-oh, okay, this is the set deck. The set deck, actually, we had color now. And let me just, I'm trying to move things off here so I can actually see. Let's get rid of that. So yeah, so there's 81 cards here floating around. And so here's an idea. What's the third one that goes here? You can find it in the mess and put an X on it, or you can just tell me. Ah, good job, Sophia. So by the way, so this is a game, right? So we'll talk a little bit about the math behind it, but the first thing we might want to say is, what are the rules? You guys seem to know how to do it, but can someone put in the chat what they think the rules are?
Seems to be a set, it has to either all be, each attribute has to be 3 of the same or all three different ones.
That is correct. And you have not played this game before?
Now that I think about it, I have played it like once. Okay,
yeah. So that's, but you know what? If I had just said, oh, all 3 the same or different in each attribute, it just sounds kind of technical. And I've discovered, I've been teaching this for many years. In fact, this tells you a little how old I am, sorry. But the first time I played set was in 1992, which is before you were all born. Savannah, maybe Savannah was alive then, I'm not sure.
No, I was born in 96.
Okay.
Almost.
Right. Well, anyway, so yeah, so it's been around for a long time. Anyway, and so I used to teach it with the definition and everything, and people would like, it took them so long to figure it out, but it looks like you got it. So good job with that. So I'm just going to show you some of the math that we do with this. And then we'll play the game in a few minutes if you guys want to actually play. So this is often if I have a bunch of people, I put them in a breakout room. So notice we went from 81 back to 9. When we want to study something mathematically, we have to make it small because otherwise it's too complicated. So one of the things that I want to ask you guys to do again is, so I put these in a certain order, 1 through 9, is write down the sets again, but this time it's more organized. And I'm just going to clear the things on the side that we have. So these are some of the kind of questions that we learn in my class. And moreover, these are questions we've looked at for research too. Like you could ask, how many sets contain the one diamond? So that's an interesting question. How many sets are there with that? How many sets are there in total? Choose 3 random cards. What's the probability? So we're not going to go through all these. I mean, actually in the class, we go over these over, like the period of a month, we do this and we do some other games. So I don't expect you today to do all of this, but I do just want to let you know some of the mathematics that we're interested in here. And let me clear this. So if you guys want, you can write down, you can write down on your own paper. You can try to let me know how many sets you find. If you want, you can list them over here. We can list them again by number. But you can also just write them on a piece of paper. And I do want to let you know that if any of you have had combinatorics, studied a little combinations, permutations, you can compute this using some of those tools. But I like to start off just kind of by hand. And most people who play set don't know the answers to these, even if they've played a lot. Okay, so no one's writing any yet, so I'm going to write one. You ready? Okay, here's one. 1, 2, 3 is a set. You can put them in chat too, or just yell them out if you want.
4, 5, 6, 7, 8, 9.
Oh,
All the vertical and horizontal. And
Oh.
and the 2 diagonals.
So how many is that?
That's 8.
Okay, is this Xander speaking?
Yep.
Okay. Cool.
And also, like, not only the diagonals, but it can be like 7 to 6, for example.
Oh, there's some other things going on here. Yeah, that's called an off diagonal.
And then also 4, 8, 3 off diagonal the other way.
Right. So so we could list them all, but yeah, so how many are you finding?
Does that mean there's only 12?
Good question.
3 vertical, 3 horizontal, 3 for one diagonal, and 3 for the other diagonal?
Looks like it, doesn't it? Okay, 1, 2, 3, 4, 5, 6. Diagonal, diagonal. And then these kind of funny ones. Let me see, I think I might have a good picture on the next page. But before we go, so what happens is there's some interesting geometry here. This is called a finite geometry. And it's interesting because it sounds like, actually, why don't you guys put in the chat what math class you're currently taking? That would give me a sense of where everyone is. What kinds of things and if I can find the chat. It's hard when I'm sharing. Okay, chat. Okay, here's the chat. Okay, so put the name of the math course you're currently taking in school. Is no one taking a math class? Are you having trouble finding the chat? statistics, calculus, calculus in Ukrainian system, also had comptroller, okay. Calculus, now, Leah, you're in statistics. Are you a junior or senior? Senior, okay. Did you take calculus already or statistics instead? And statistics instead, okay, cool, okay. So, by the way, especially those of you that have already had calculus, you probably wouldn't definitely, like I said, if you're headed towards STEM major, you wouldn't be taking this puzzles and games class, but actually the stuff that I'm telling you is stuff that comes much later. So you guys are really on the ball, and it's very exciting to have you. You can ponder, so you could also ponder how many sets contain this. You can also do the probability. Often what I do is we actually do trials, but since you guys have such a good background, I'm just going to actually show you how the probability works. So if we want the probability, then we need to have the number of ways to make a set, and we have to divide it by the number of ways to pick 3 cards. So in other words, you just want the proportion. That's the probability in this case, is just saying, well, of all the ways I can pick 3 cards, I know there's 12 ways I can pick a set. And how many ways can we pick 3 cards out of 9? Does anyone know? I don't know how much people have seen.
It's gonna have something to do with factorials.
Yeah, I mean, I could
Do
show you
like
the
7
formula.
factorial plus or times 6 factorial, 5 fourth, something like that.
Well, I'm going to do what I call the slots method. So I'm going to take, how many ways can I pick the first card? How many ways can I pick the second? And how many ways can I pick the third? So if I have 9 cards, how many ways can I pick the first card?
9.
9. Good. Yeah. Okay. And then how many ways can I pick the second card?
8.
Once I pick 8. And how many ways can I pick the third?
And the third would be 7.
7. Okay. And so that is 9 times 8 times 7. But here's the thing. Remember how we said the order but order doesn't matter. So I overcounted. Here, let me just make this. Does anyone know how, for example, let's say my set consists of cards, A, B, C.
Would you divide it by
we have-
6?
What?
3 factorial.
Yeah, 3
divided
factor,
by
right,
3
because
factorial.
A, C, B, etc. So since order doesn't matter, there's 6 ways to choose those. You guys are very good. And so I have to divide by 3 factorial or 6. Okay. And so what is 9 times 8 times 7 divided by 6?
84.
What? 84?
84.
Okay, and so now we know the probability that if I just grab 3 cards randomly, the probability is going to be 12 over 84, which is 1 over, we could find a decimal, but we could actually, what happens when we reduce this?
I mean, 1 over 7.
Yeah. So when I do this, like if you took a 9 cards and just did a bunch of trials, it should be about, about every 7 times roughly you should get a set. Of course, you often have to do a lot of trials to get the exact probability. Now, so by the way, so this, we can also use this to count sets, but I'm not going to go into it because I want to do some more fun stuff with you. So let me just see, I'm trying to remember what else is on this Jamboard, excuse me. I'm going to clear this. Okay, let's clear everything. And let's go here. Okay, so let me just see what else I have on this Jamboard. Oh. Let's just ignore this. Oh, yeah. Oh, here's another, the other question that's kind of interesting is find the largest group of cards that contains no set. So I'm going to go back a little bit and I'm going to tell you guys some cool stuff. Okay, so let's go back here. Let's look at number 4. Let's find a group of cards that doesn't have any sets in it. So for example, if I pick 1 and 2, right? Then 3 makes a set, so I have to kick it out. So now I can add anything else. But what happens when I add 4? What do I have to kick out now? Which ones?
7.
Anything else?
And 9.
Right, for that off diagonal. And so now, and those are the only ones. So now what happens when I add 1 more? I'll add the 6. Now what do I have to kick out?
5.
Mm-hmm.
And the 8.
Why the 8?
Because then you'd have the 1, 8, 6 set.
Right, the off diagonal. Okay, so it turns out that the answer here is 4. In other words, oh, wait, I didn't want to do, okay, 4. In other words, if I pick 5 cards, we haven't proved it, but if you pick 5 cards, you're guaranteed to have a set in it. Now, that turns out to be an actual problem that mathematicians find interesting. So I want to go on a little bit. Okay, let me just, I have to switch from one mode to another. Sorry about that. So now let's go to the next thing. So that was 4. So now the question is, how about here? So we could also count, like we can use some combinatorics and some probability. Like this time we would, yeah, we could use some counting techniques and we can answer these. But let's look at this problem. So what's the largest group of cards that contains no sets? This is a little harder to think about. Or what's the number? Does anyone want to make a guess? So for example, we know that if we just have 9, once we pick 4, so if I just picked 4 of these, I'm going to put hearts on them. So if I pick like 4 of these, then I know I have to X out all the rest of that color or that shading.
Would it be 8?
That's an interesting, yeah, that's very interesting. So, and what would the other ones be?
Say those same 4 on one of the other colors.
Okay. Yeah, so if we do that, well, if we do that, we definitely X out. But how do we X out the ones in the third? So it's a little trickier.
Well, you'd X out those 4 in the top left corner on the third because they'd make so like vertical sets. I'm not sure about the other ones, but
Yeah.
Is it 12?
Pardon?
Is it 12?
Is it 12? Well, that's
Yeah.
a good question. If we put 12 there, the question is we have to figure out what to kick out here. So for example, if I take this card and this card, what's the third one that makes a set?
the top left in the third group.
Right. So actually I have to X this out. So it's not obvious. You guys can think about it, but it turns out we actually have to X out all of these. So it turns out with these are called a maximal cap, these 8 cards. By the way, I don't get this far in my puzzles and games class. You guys are getting the advanced treatment. Okay, so that's called a maximal cap, meaning if you add any card, you're gonna have a set. But here's the interesting thing, however. There is one with 9. Not obvious. It's different. You have to do something different. And that just shows you how like interesting and beautiful this game is in terms of mathematics. And by the way, this is very different than the math you do in school, I presume. But this is how mathematicians do things. So I'm going to clear this, and I can't remember what else was on here. Oh, this is just showing you the whole thing. You can ask the whole thing. So by the way, the answer for that was 9 is the maximum you can get. When we have this whole deck, can anyone tell me a guess for what they think the maximal cap is here? And by the way, any guess is valid. It should be a
Would it
fraction.
be 16?
Okay, so here's the thing is with 16, you can actually, you get what's called a complete cap. In other words, with 16, you can't add it. You can do 16 where you can't add anymore. But you can also, if you're more clever, you can find a higher number. Anyone want to take a guess? So here are guesses. 16. Anyone else have a guess? You can be wrong. I'm going to pause for a minute so I can see you guys. I just want to tell you something. You can find it with 16. It turns out, though, you can find one as high as 20, which means it's possible to lay out 20 cards and there still not be a set. It's very hard to come up with this. And just so you know the level of math here, that was published in a paper in 1971. Before set was invented? How could someone prove a theorem about set before it's invented? Does that even make sense?
Well, just because they were looking at things about theoretical sets of variables. How it works.
It's because this is of interest to mathematicians. And so they actually so this notion of what's called a maximal cap was a problem in what's called finite geometry. Those set cards, sets form what are called lines in a geometry. So by the way, this is not really part of undergrad math usually. So I just wanted to let you know that we're getting into some real territory. So this is the kind of stuff that I do in my research with students. So they figured out it was 20. And if you add another attribute like background color, then the number is 45. And if you add yet another attribute, the number is 112. And guess what happens when you add another attribute? 7th attribute.
It stays on 112 or what it was.
That's a good idea. Anyone else have an idea? The answer is no one knows. It's an unsolved problem in mathematics, and researchers are currently working on it. So here we are in just a little sample puzzles and games class, and we hit upon an unsolved problem in math. So the difference is, now if you come here and you take calculus, you might not see that much unsolved problems, but the way we teach here is really about ideas and thinking. So even in a calculus class, you're not just gonna be computing. But yeah.
What were
and it-
those numbers again? For the
numbers?
For the,
Yeah, I'll put them in the chat. They don't form any interesting sequence. So the numbers, if you start earlier, so they're 4, 9, 20. Oh, and by the way, the 112 was just found a few years ago. These things are so big that even you can't even run computer trials anymore. That's one of the reasons this is unsolved. So now I'm just going to do something fun, and we're going to play the daily set puzzle. All right. So I'm going to share my screen. So, you guys just learned a lot about the math of a game without actually playing it. So it turns out every day, if you go to set.game.com, set puzzle. In fact, I'll put it in the chat just in case anyone wants to play on their own. So I'll tell you what I really love about this game, though, is that, video games, you finish and they send you to the next level and then you never do anything else. This puzzle, when it's over, you got to wait till tomorrow. Okay, so what we're trying to do here is we want to find as many sets as we can. Anyone want to anyone find a set? You can yell it out, you can annotate, you can chat, and maybe I'll see it.
Yeah, so we have 3 striped red ovals, green ovals, and purple.
Oh, good.
ovals.
Okay, good. That's the first one.
at 1, 2, 3 of the green striped objects. Oh no, never mind.
Yeah.
We don't have squiggles.
That's okay.
Or 2.
Oh, sorry.
Yeah, go ahead.
You could do the green squiggle, the red diamond, and the 3 purple ovals.
Oh, good. They're all solids. Yeah. Great. Now, by the way, I haven't looked at this today yet, so I don't know what they are. Sometimes the last 2 are often a little tricky to get, but I'm not going to think hard unless you guys get stuck. Oh yeah, you can enlarge this. And a lot of people play this game. Very few people actually know about the math, but I do want to tell you that a friend of mine wrote a puzzle called The Joy of Set. I mean, a book. I actually use this as my textbook for the class, and I also use it as background for my research. Not The Joy of Book, sorry. The Joy of Set.
So there is one solid squiggle, then there are green one, sorry.
Oh, green, okay.
Then there are 2 green diamonds
Okay.
and 3 green striped ovals. No,
Oh,
green ones.
green, sorry. Yeah. Okay, got it.
Yeah.
Yeah, sometimes you have to stare for a while. Oh, by the way, notice they laid out 12. Remember, you can have up to 20 without any in them, and this one, but yet this layout actually has 6 of them, which they design on purpose. Let's see, I haven't looked. I'm gonna have to look. Savannah, are you still here? If you find one, you can share.
I also have another one.
Okay, go ahead.
3 solid purple ovals,
Okay.
then 2 red ovals. Yeah, and one
Oh,
green stripe.
here. Okay. Good job, Sophia.
Um, the 2 red ovals, the 3 green diamonds, and the 1 purple squiggle.
Nice. Okay, there's one more, guys. Uh-oh. Let's see. We only have like 11 minutes left. And I have to show you something else too. So let's see if we can find this.
Would it be? Oh, sorry. Never mind. I
Yes, okay.
thought that was on there.
Oh. Oh, wait a minute.
Oh, is it?
Go ahead. I think I found it, but go ahead. Maybe
Oh,
you,
I found it. And then it's the purple squiggle, the red, the 3 reds, and the 2
nice.
green, 2 green
Nice.
diamonds.
Okay. Congratulations. It took us 5 minutes and 20 seconds. You can also, I never do this to win a free game, but maybe it'll work. Anyway, so you could try this any day that you want. So I just want to pause here and see if you have any questions before I do my last activity. Do you have any questions about like courses at Bard or anything like that?
That was really fun.
Yeah, you know, I really, one of the reasons I went into math is because I grew up loving puzzles and games. And math is very similar to the kind of thinking that you do. And so I really like this.
That's not something I can help with yet.
What? Oh, sorry, my watch is talking to me. So I really like to turn math into games and turn games into math. That's something I've been doing for the last 10 years. I also do a lot of outreach. If you do come to Bard, where we go and we do math and puzzles and games with K to 12 kids. In fact, there's a Discovery Festival, I think it's next weekend, and a bunch of Bard students and I are going to come and we're going to teach them some of these games. Now, we're not going to really teach them the math. But you learn sort of mathematical thinking from playing the games. And of course, if you're in college, you can actually learn more of the math. Anyone else have a question? Okay, so in our last few minutes, I'm gonna, it's funny, I wasn't sure who, I'm gauging this by the group here. So I want to tell you that I had a senior thesis student in 2012 and 13, and we decided to do something like set, but we decided to have 4 states for each attribute. So we made a game, and it's called Quads. And so hardly anyone has heard of this. So I just want to tell you, I'm going to just teach you how to play it a little bit, if I can find it. Okay, hold on a second. And I actually just, my students made an app and I just hired someone to make a more professional app. So I'm going to teach you guys. And like I said, a lot of people know set if you ask some people, but probably hardly anyone has heard of this game. Okay. So this is called Quads. So we're going to start off with make a quad. Okay. So we have a 3, and a 4. And we have to ask, what is the 4th one going to be? And you know what? Actually, I'm going to go back to something. I'm going to go back to something here. I'm going to go to find a quad. So we're not going to give you a definition. It's similar to set, but it has a new definition that's sort of a twist. So one of these rows is a quad and the other 2 aren't. Does anyone want to guess? So I'll put this in the chat, by the way, so you can play with it at home if you want.
Again, what should we do with it?
Yeah, so no, in this one, we're just trying to decide which row we think is a quad, like satisfies a nice pattern. I didn't tell you the definition. So this is a little tricky. So actually, maybe we'll go back to one. Let's go to one color. Let's start with one color. Okay. All right. Okay. So a quad is 4 cards that satisfy a pattern. It's similar to set, but there's a little twist. So my first question is, do you think you see something that would make sense? Or if you want, I can show you one.
You could do.
Would it be something?
Sorry, go ahead.
Okay.
Yes.
Would it be something such as the
This
single circle, the 2 hearts, the 3 squares, and the 4 triangles?
Excellent. Right. And so this goes over here, by the way, just to show that you found it. So that is in number, they're all different. And in shape, they're all different. So the thing is, we have that, but we found that we didn't get enough quads, so we had to make another rule. So the rule is that we can have something called half and halves. So as long as everything's even. In fact, this has been published. It's called Even Quads. It was published by the Association for Women in Math. So for example, actually, do we have another one? Let's see. Okay, we definitely have one. Let me find one. Okay, so let's look at these two. Let's look at this. See, we have 2 4s. So instead of having all 4s, we can have 2 4s and 2 3s. So if I do that, then, so you just look at them in each attribute. So in shape, they're all different. In number, they're 3, 3, 4, 4. They're 2 pairs. So they can be all the same, all different, or 2 pairs. So now, does anyone see one here? This is harder. This is harder than set.
2 singles and 2 doubles.
Okay, here's
Like,
which 2 singles?
A heart and a triangle.
Heart and a triangle. Okay, yeah. Okay, and now is this last one a quad, do you think?
That looks like a quad.
Yep, it is. And so mathematicians would then say, oh, is it always a quad at the end? And that's something that we've studied. So yeah, so this is the one color game. And then now that you've seen this, now let's go to find a quad. Now let me ask you, I'm going to tell you one of these is a quad and 2 of them aren't.
The one in the middle.
Yeah, let's check it. So you can go and you check. Yes. And what's wrong with the other ones? Well, I nicknamed this 3's a crowd because if it's not a quad, there's 3 of something. Like here, there's only 3 different colors. So that's not a quad. Here, oh, there's also only 3 different colors. So that's a no. So this game is much harder to play, but let me go back to here. Especially, it's much harder to play here. Now, by the way, see how I added a card? My students and I, just last summer, proved that if you have 10 cards, you're guaranteed a quad. And if you have 9, there's a 96% chance. That's the kind of stuff we do in our research. So, does anyone see one? So sometimes these are really hard. I know mathematically there is one, but that doesn't mean I can find one.
I think a square, single one,
Okay,
then 2 blue circles,
okay,
3 pink triangles, and 4 green hearts.
nice. Okay, so that's how, I just want to show you. So that's how this works, this game. And then we even have a daily puzzle too. You know, we want it to be better than the set puzzle, so we make you find 7 instead of 6. That's not why it works. With 8 cards, you actually, I think you can't get 6. But so this, then you could do this and you could start finding them. And we only have like a minute left, but does anyone want to find one at least? Since there's 7 in there, it's probably not going to be too hard to find one.
You could do the green squares and the blue squares, and the pinks and yellow squares as well. Right?
Okay, all the squares. Yeah. I'm just going to show you another one. We do those. There's a whole bunch. These are designed, so there's going to be a whole bunch of them.
Could you do the red and green squares and circles? Not the one green square.
Oh,
but
wait,
the other.
wait. Red and green, what?
The squares, the 3 and 4 red, green squares and circles.
3. Oh, 3, 4, 3, 4. Oh, we already got.
No, the I'm saying this wrong. 3 red squares,
Oh,
3
these.
green circles.
Okay.
Um,
Those 2? Oh,
yeah,
and then
the-
these
and the-
2?
no.
Oh.
Oh, I guess that is one.
That one was, like I said, there's 7 of them, so they're kind of, yeah.
These ones are organized in
One
a
by
T
one.
shape.
What? Yeah, say them one by one.
Okay. Top left corner.
Okay.
The one to the right of that.
Okay.
And then the ones below and to the right of that one. The red and green.
Wait. Oh, right here? No.
No, no, no.
Okay, sorry. Just tell me. Okay, I'm gonna.
I'm pretty sure
I'm
this
gonna
is
stop.
gonna turn out to not be a quad and it's gonna
Yeah, just tell me what they are, because I'm.
Okay. Red squares
Got it.
and 4 green.
Thank you.
Okay, it's a quad.
Okay. So we found 4, and you're gonna be annoyed, but we stopped. But you have that. You can try this at home. You can teach people. And I think I'm gonna stop, and I'll answer any question. We can stick around for a few minutes. I just want to thank you for all for coming. This is because you because you're all seem to have such a strong background and interest. I was able to. I planned something very different because I thought I was going to get more different kinds of people. So I mean backgrounds. But I just want to show you something really quick. I have to change my background to nothing. So you can see, now you can see I live in a house. Okay, with the kitchen. But I just want to show you. So these are the cards. These are what the cards actually look like. They were published by the Association for Women in Math in honor of their 50th anniversary. And if you look on the back, they actually have profiles of women mathematicians. So this is kind of a special card deck called Even Quads. And so that was really nice that they made that. Okay. All right. So I want to thank everyone for coming, and feel free to email me if you have questions about Bard, math, or science. Or even anything. I've been here for a long time. So, anyone have any questions? And Sophia, thank you for staying up so late.
Yeah, that's fine.
Let me try.
We have like
What?
we have a national holiday, so I have a day off, so I could stay a bit later.
Oh, okay. And California, okay, so California, it's only 3 p.m. And Leah, we actually study Sudoku. There's a lot of math behind Sudoku, but it's not about the numbers. The numbers in Sudoku might as well just be symbols. that it's really logic, but there's some interesting math. And Xander, you're from Michigan, Traverse City. And oh, Pakistan, Rabia, is it Rabia? And Rabia, what time is it in Pakistan right now? 3 a.m. Oh, wow. Okay, that is, well, thank you for, and here I made you do work at 3 in the morning. Sorry about that. So, and does anyone have any last minute questions or comments?
I put my email in the chat. I can answer any admissions questions that you may have, as well as I graduated from Bard in 2019. And so I can also answer any questions that you might have about what it's like to be a student at Bard. I graduated from the film program. And so if you are interested at all in that, I can also answer those questions.
Yeah, and I also want to ask, so most of you are interested in math or science, and I wanted to know, are you looking for a small college or do you want to go to a big school? What kinds of things are you looking for? If you want to share anything in the chat or out loud. And I can tell you what Bard offers and or what it doesn't, because we only want you to come here if it's a good fit. One thing, Bard is a good place if you like math or science and you also have other interests, because I mean, if you only like math and science, you could go to Technology Institute or something, but you really get a broad background here. And you get to talk to your professors and get to know them. I keep in touch with a lot of Bard alums. I still do projects with them and stuff. Okay. So, Xander, Rabia, Leah, any comments, questions?
Okay, well, we can go ahead and wrap things up. Thank you all so much for coming and participating. That was very lovely to watch. Once again, Lauren and I have our emails in the chat if you guys want to write those down if you ever need them. And yeah, thank you all so much for coming.